Hi all, I am Abhishek PB and this video is on the topic on my embedded system internship project microwave oven, and this is the basic content I am going to follow in this presentation: requirement of the project, analysis of the project, design, development and implementation. First, on the requirement and analysis part, the main purpose of the project is to develop a microwave oven. I'm going to simulate a microwave oven in this video. And we all know what is a microwave oven. It cooks food using microwaves. Microwave are a form of electromagnetic radiation. Polar molecules in the food are made to rotate and produce thermal energy in a process known as dielectric heating. And we all know that oven has got several cooking modes, and we are going to uh, simulate all the cooking modes in this project. And uh, next is a software requirement in the project. I used a PiximLab simulator and MPLab IDE, that is an integrated development environment I used here, and X8 compiler is the compiler I used in the project. And the basic project analysis or the user requirement is shown here. First, in the project, after simulation of the project, the first screen will be a powering on microwave oven screen. Will be the first screen we are going to implement. Then the various cooking modes are displayed. It will be micro, grill, convection and start. These are the cooking modes here in this project. And next, if you are going to select the if the user selects the first, that is the micro mode, then operating power will be shown in the next screen. Within 2 seconds, the option for setting the time will appear for the user. User can enter the time in seconds and minutes. It's given as 50 seconds and 30 minutes. I entered it as it like this. And next, if the user process the hash in the matrix keypad, the process will proceed, and if the user clicks the star, then the time set is cleared. Next, the process starts by clicking the hash button. Then the user can have options to pause the process, resume the process after pausing, and stop the process of cooking. When 6 on the matrix keypad is pressed, the process stops, and again the cooking mode display is displayed on the screen. Next, the set time. Next, again, if the user presses the two in the matrix keypad, then the grill mode is selected, and the procedure is same as that of the micro mode. So again, if 6 is pressed, the process stops and cooking modes are displayed again. Then after clicking the third, that is the convection mode, an option for setting the temperature is displayed. Uh, Here the user have to input the temperature. If the temperature should be given below 250 degrees Celsius, and if it's given above 250 degree, then an invalid temperature screen will appear and the buzzer will be on. And so the user enters a temperature below 255 degree. Here I gave a value of 100 degree Celsius. Then the process will be same as before in the convection mode, but before that, the oven preheats for a 180 seconds by default when the hash is pressed. Hash means enter. If the process begins, it preheats for 180 seconds, and the set time after preheating the screen is set. After preheating, the screen will appear again, and the user have to input the second and minute. Then the process will be same as before, and after that, if the last and the final mode, that is the last mode is pressed, the time starts instantly by 30 seconds. If we press the start or resume button, the user can start, resume, pause, and stop. The time will be by default 30 seconds in the start mode, because we don't want to give any values. We don't want to set any time in this uh, mode. And after the time is finished, the cooking time up screen will pop up, will appear, not pop up. And if the if pause if we have to increment the time by 30 seconds, then 4 is pressed. Then about the design part, architecture of Pixim Lab. This is the basic architecture of the Pixim Lab. We have digital keypad, matrix keypad, CLCD, buzzer, and we are focusing on the matrix keypad, CLCD, and buzzer in this buzzer and LED in this project, because we have to implement the microwave oven. And this is the basic pinout of the PIC 16877A microcontroller we are using here. It has got 40 pins, and it's basically a 8-bit microcontroller. Its operating voltage is from 4.2 to 5.5 volt, and it can operate up to 20 megahertz frequency. Next, these are some of the features of the microcontroller we are using here. It support I2C communication. Comparator modules are present. EEPROM is there, and these are the features. Then about the specification, I'm not going deep into this part because we don't have enough time for that. It's bus width is 8-bit, pin count is 40. All the information is given in the slide, the specification. And the next peripheral is the matrix keypad. Matrix keypad is a small compact input device. Here we are using a 4 into 3 matrix keypad. That is, it has got 4 rows and 3 columns. So we are using a 4 into 3 matrix keypad here. It's used for selecting the cooking display. We are selecting the cooking display using this matrix keypad in this project. And the basic working of the keypad is given in this slide. And this is the diagram, circuit diagram of how to connect the matrix keypad with the microcontroller. Here the RB0 to RB2 acts as the input. This is the input port, that is port B. RB0 to RB2 are the input pins, and in the port D, RD0 to RD3 are the output. That is, a column is the input and those are the output. Microcontroller scan for a button first state. Initially, the microcontroller picks and set the row as low, and then you check for the column line one at a time. If the column again remains low, it indicates that the key is not pressed. And if it's showing high, then the microcontroller identifies the row which was set to low and which column is set to high. In this manner, the key pressed can be identified. Next, about the CLCD display. This is the main this CLCD display. Here we are using a 16 by 4 CLCD display, and it's used for displaying the ASCII characters. It support both 8-bit and 4-bit modes. So here in this project we are going with the 4-bit mode, as we had to implement the matrix keypad also. So we are going with the 4-bit mode in this project, and these are the pinout of how to connect the CLCD display with the Pixim Lab. Basically, if R bar W is 1, then it indicates read. But in this circuit diagram, it's always grounded. So by default, it is low, and we can perform the write operation. And if the RS is 0, it indicates the instruction, and RS is 1, it indicates as data. A microcontroller interprets it as data. And this is the buzzer. Buzzer we are using, as I said earlier, buzzer is used for selecting the convection. In the convection mode, if we are giving a value greater than 250 degree for the temperature, the buzzer will be on, and after each time after the process entire cooking process is over, the buzzer will be on as an indication. Next, about the timers. This is a GIF showing the basic working of a timer in PIC16F microcontroller. And we all know that a timer in a microcontroller is specialized type of clock which is used for measuring the time intervals. It's used to count the cycles and perform a particular action at a specified moment, or optionally start an interrupt cycle. In the PIC A16877A microcontroller, there are three timer modules: timer 0, timer 2, and timer 1. And here we are using the timer 2 module. This is the block diagram of the timer 2 module. The main reason for using the timer 2 is test bit. TMR on is a major advantage of the timer 2. So we are using this in this project, the timer 2 in this project. Timer 2 can be shut off by clearing the control bit. That's why this TMR timer 2 is used in this project. And about the development part, again, the software tools are explained here. MPLab. MPLab is a proprietary freeware integrated development environment for the development of embedded application on PIC microcontrollers, and is developed by Microchip Technology. Then about the PIC lab simulator, given here, it's essential. PIC lab is a real-time emulator of development boards with integrated MPLab debugger, AV or GDB debugger. And we have to, for coding, we have to maintain all the time. We have to maintain our main.c file as simple as possible, so that we can understand the code in better way. And we have to split all the peripheral codes into different separate files, so that anyone can understand the code and interrupt the code efficiently. And now I'm going with the implementation. I'm closing the PPT so that I can show you the implementation of the project. And this is the MPLab ID, and this is the code. And here in the source file we have the ISR main.c, metrics keypad.c, timer, all the C files, all the peripherals, and the main file. And in the header files we have all the hex files loaded. And this is the basic code. And next I'm going to show the simulator PIC lab simulation. And I'm going to, yes, first if we on the start simulation, the power on screen is displayed and the cookie modes are displayed. First I'm going to select the micro mode. Here, see here the power is displayed, operating voltage was displayed, and we have to select the time. In the metrics keypad I'm going to give the time as 50 seconds and 1 minute. Okay, I'm going to start the process. Yes, the process starts. It is indicated by the fan. Cooling fan is on. The fan is on, so that we can understand that the process start. So I can pause by clicking 5. And I can stop by 6. Yeah, some problem with the code, some problem with the simulator here. So okay, I'm going to restart the simulator. Okay, again, excuse me. Okay, the process. First I'm going to select the micro mode. Then power is displayed. Then time 1 minute 20 seconds is given. The process is start. If 5 is pressed, the process is paused. If 5 is pressed, the process is stopped. And to resume 4 is pressed. Okay, everything works fine. And I have to stop the process, so I just clicked 6. So everything stops, and we are back to the cooking mode display, and the convection and grill mode start mode is there, and we are going to the grill mode next. Grill mode is same as that the uh, micro mode. I'm going to give some time, anytime you can give. I'm going to give 12 minutes 20 seconds. Okay, I'm going to start the process. The process start, and to pause the process, again I have to stop the process. Okay, I stop the process. Then the convection and the start mode. Okay, the convection mode. In the convection mode, in the start mode, I'm going to show the start mode first. In the start mode, initially we don't have to give any time. We don't have to set the time. It starts from 30 seconds by default. And if I have to increment the time, I have to give the 4. But I am not going to increment the time right now. And this is the microcontroller. This is the buzzer, and this is the fan. These are the peripherals we are using, and this is the matrix keypad. Then after the time stops, we can see the cooking time up, and the buzzer is on. So again, at last I'm going to show the convection mode, and first we have to select the temperature. I'm going to give intentionally a temperature greater than 250 degree. So I'm going to give 300 degree. Okay, then I have to enter invalid temperature. It's showing invalid temperature. Everything works fine. And next I'm going to give a temperature below 250 degree. So I'm going to set temperature 200 degree. Okay, then again enter. See the time remaining. This is the oven is the pre-starting to from 180 degree, from 180 seconds counting. For 180 seconds it will be preheating. This is all about the project. Thank you.